Okay, guys, so this is your short, sweet, to the point of real roots, imaginary roots. Roots, remember, are your x-intercepts, your solutions, um, your zeros is another way to discuss this. And back when you did quadratics in Math 1, you would look at a parabola and however many times it touched the x-axis was the number of solutions you should find. So real roots is what we're going to deal with today, and so that means where it crossed the x-axis. So looking at this polynomial, we know it's a 1, 2, so it's going to be a 2 1/3 degree. So that means there needs to be 3 zeros. So our zeros would be at -2, +1, and +3. So looking at this polynomial, we have 1, 2, 3, 4. So we know there should be 4 roots, 4 x-intercepts, 4 zeros. So we have one at -3, -2, 3, and 4. So -3, -2, 3, and 4 would again be your roots or your zeros, x-intercepts, so where it crosses. And we know there has to be 4. So 1, 2, 3, 4. Now looking at this graph, I have 1, 2, 3, 4, 5. So I know I need 5 solutions to be able to write this polynomial. And I have 1, 2, 3. So I have 3 real, which means I could have 2 imaginary. Now, the important part about imaginaries is they always travel in pairs. So you have to have an even number of imaginaries. You can never have 1. There can only be 2, 4, 6, 8 imaginary solutions. So in this point, we see that there's 3 real. We know it's a 1, 2, 3, 4, 5 directional change. So we know that this function is going to have some sort of x to the 5th, depending on what else goes on around it. So that means we had 2 imaginaries. So looking at this, we know it's 1, 2. So it's a quadratic, but there's no solutions. So there's no real solutions. But there has to be 2 imaginary. Because otherwise you wouldn't be able to write this polynomial. And again, imaginaries must travel in pairs. So they have to be 2, 4, 6, 8, and things of that nature. You can't just have 1 imaginary. You can't have 1 real. So talking about real solutions, when they cross through, this is multiplicity. So multiplicity is the word you want to remember. And that's how many times that solution actually occurs. So in this case, when it crosses through, that's a multiplicity of 1. So that means it happens 1 time. When it bounces, this is a multiplicity of 2. So I call it a bounce. Bounce is a multiplicity of 2. Now, when it flatlines, because this is a 1, 2, 3 directional change, 1, 2, 3, this is going to be a multiplicity of 3. It still crosses through. So all odd multiplicities cross through the x-axis. It does go 1, 2, 3. So again, that's why this has to be a 3 multiplicity. So it's going to be a cross through, but it flat lines a bit. Flat lines. Now, if it happened to have been coming from up here and it flatlined on the x-axis and then came up, that's a bounce, though it's a long, flat bounce. So there's probably going to be a multiplicity of 4. Not something we're going to deal with a lot, the multiplicity of 3 and above. We're more focused on the 1s and 2s, but just so you know that that does exist, that's that multiplicity of meaning it happens more than 1 time. So looking at this one, I have a 0 here, or a root here at -3. That's a bounce, so it's going to be a multiplicity of 2. It crosses through at -1. That's a multiplicity of 1. And they typically don't even write the multiplicity of 1 out, but just so you know. And then here, it flatlines at that 4, because again, we got 1, 2, 3, 4, 5, 6. So 1, 2, and then we have the 1, so that's 3. So we know this is going to be a multiplicity of 3. Because it did cross, but it flattened out. Looking at this one. So here it bounces at that -2. So we know we have a -2. It's a bounce. So it's going to be a multiplicity of 2. And this one crosses through at the 3, and that's a multiplicity of 1. So that means the -2 happened twice, boom, boom. And then 3 happened once. So again, that's because it's a 1, 2, 3 degree function. Hopefully remember this means our leading coefficient was positive. Let's go with one more. So again, it's going to cross through at -4, cross through at -4, which is the multiplicity of 1, cross through at -2, multiplicity of 1, and bounce at 3. So 3 multiplicity of 2. All right, so that's your basic introduction to roots, zeros, x-intercepts, and your understanding of multiplicity.